the least fun is when you're stuck in meetings that aren't of interest and nothing much is coming up in the meeting and you have to sit through it. That could be one of the worst things, but it's not too bad.
Do you travel much in your job?
I haven't traveled too much in this job. I've gone to Canada a few times where one of the instruments is being built. I went to Spain once where the meteorological station is being built. And then I've gone a fair number of times to NASA Goddard, which is near Washington, D.C., and that's where the sample analysis at Mars instrument that will look for the building blocks of life on our mission is being built.
And you said also that you'd been to Hawaii. What was that for?
That was when I first came to the Jet Propulsion Laboratory. It was a research project to look at this 1984 Mauna Loa lava flow, and it was a special time.
That sounds fun.
Yeah.
What new things have you learned in the course of your career?
Oh boy, that'd be a ton of things. All these things that we found, especially with Spirit and Opportunity rovers, there was just a lot of things that surprised us. Finding the sulfate sandstones, the evaporitic sandstones at Meridiani was not something we could tell from our orbital images, that we would find these layered sedimentary rocks put down by water that had been flowing on the surface of Mars in the past. So that was very exciting. And then for the rovers to have lived so long, Spirit went up to Husband Hill, came down the other side, and found an amazing array of different kinds of rocks that, again, we never expected. Even got to home plate, which had these layers in them, and that was, a great finding finally for Spirit to get there. And so it looks like those might be volcanic explosive rocks or sedimentary rocks, and so that was an important new thing that we learned. I just learned. It's fun. It's fun to be involved in these kinds of missions, and you can apply what you find there to what you're studying on the Earth about the geology of the Earth too.
What's the most exciting thing that Spirit and Opportunity found so far?
I think I touched on them in what I was saying. So for Opportunity, finding where the water had been flowing on the surface of Mars from the ripple patterns that we saw there, and the little hematite spirals on the surface in the rock and in the soil, that was a sign of past liquid water because of the hematite mineral in them, and that needs liquid water to form. So there was a clear story of past liquid water where Opportunity went. And then for Spirit, actually one of the biggest findings came after being at home plate and being nearby home plate. One of the wheels wasn't working right, and it dragged its wheel, and it dug in the soil and revealed this white kind of material. And when they analyzed it, it was almost pure silica. And they think that pure silica material probably formed from hot waters, like some kind of hydrothermal activity. And so that would be a very good past environment for life if that was how it formed. So that was a very exciting find for Spirit.
What's the most exciting thing that you've done in your career?
Oh boy. Most exciting. I think it's when Spirit and Opportunity landed. That those were the moments that were, you just don't know if it's going to work, and then so when you get that first picture back from each of those rovers, it was probably the highlight for me. Going whee. Yeah.
That must have been really exciting.
Yeah.
What are some jobs that you've had before this?
The only job that I had before this was after I got my PhD in Princeton. I went to UCLA, and I did experimental petrology, which was quite different than anything I'd done before. So we had these setups where you work on valves, and you set up plumbing so that water is pressurizing your little capsule. So you had to weld capsules. So here I was welding with torches, little capsules where I'd put rock powders in that were carefully put together. And then I had to weld those shut, and then you put them in what is like a metal bomb, and that's connected to a water line. And so you would crank up the pressure to about 2 kilobars to simulate a rock at depth. And you'd put this metal bomb into an oven and heat it up to a magmatic temperature to melt it. So it was simulating what was going on for a volcanic magma at depth. And so I was using some rocks I had studied before and doing this kind of experiments. And you'd leave it like that for a few months to let it equilibrate and see what kind of crystals would form at those conditions. And so you could set the conditions. But the work involved things like, making these valves work, checking the valves. It was like more like hardware kind of a job. And then sometimes you get done with the test and find out, oh, it didn't work, it didn't hold its pressure, the weld didn't hold, or something like that. So it took a lot of patience. You'd have to do it again and do another experiment and set it up. So I learned from that what goes into phase diagrams, which is it shows what minerals are stable under different conditions, a map that you take for granted when you're learning geology, that looks simple. And you find out all the work that had to go through to make the lines on that chart that separate the different mineral types under the different conditions. But that was a lot of fun, and it was a very good learning experience.
What are some hobbies you have, and do they help with your job?
One of my biggest hobbies is reading. I like to read, and I read a fair amount of science fiction. So I think that helps me by just being inspired and making it, again, more interesting that I'm working on a space mission. And if there's a sci-fi book with Mars in the title, I'm even more likely to pick it up. I do a little bit of garden work. But I do spend a lot of time on my JPL work, and so I don't have a whole lot of hobbies, but those are some of them.
What's the part of your job that's unique to what you do that you wouldn't be able to do otherwise?
Well, it's just, it is a very daunting task. It is very big and hard to do. And so sometimes that can be scary, and you think, oh, there's no way, this isn't going to work. But you realize that because it is so hard, that the payoff when it works, if it works, is going to be tremendous. Because that's kind of the trade. You can have a safer job that's easier to do and a piece of cake. But then when it works, you'd say, no big deal, right? It wouldn't feel as tremendous. So I think that's the unique part of my job, is that, it's really, really hard and challenging, but then if it works, the payoff will be really good because of that.
Do you have any advice for kids who want to get into geology or planetary science?
Mm-hmm. Yeah, just study math and science and keep your options open, because you don't know what opportunities will come your way or how you might change your mind later. The sciences are all related to one another. Geology nicely can pull all of them together, like physics and chemistry, and so you can use all these tools in geology. But I didn't know where I would end up, and if you just study hard and keep your options open, then later when you get to college, you can find out what you're good at and what you really like and what turns you on, and then you'll be set to be able to do that.
Okay. That's really interesting talking to you. Thanks for talking to me today.
All right. Yeah, it was fun.
It rocked.
All right.
I'm Zoe Bentley, and thanks for watching Exogeology ROCKS.